Hi everybody. In the next week or two or three, we're going to be talking lots about ratios and proportions, and this is a kind of a nice way to start talking about ratios and proportions. I'm going to look at this recipe. It's not really a recipe, don't make these cookies, but let's act like it is. And the recipe calls for 3 cups of flour, 5 eggs, 2 cups of milk, and 1.5 cups of sugar. But we only have 3 eggs, so how much of each other ingredient would we need? And certainly this will be proportional. I'm going to set it up and figure out about the flour the first thing. And I'll think to myself that eggs over eggs is equal to flour over flour. Those amounts should be proportional. So if I have 5 eggs, that'll give me, we would expect to have 3 cups of flour. But since I've only got 3 eggs, how much flour would I need? And let's use an FL for flour, perhaps. And what I got to remember about our proportion is the cross products will be equal. That is, 3 times 3 is going to equal 5 times F. 9 is equal to 5 times the amount of flour times F, let's call it. And when I divide both sides by 5, the amount of flour should be 9/5 of a cup. And really that would be 1 4/5 cups of flour. Yeah, I'll go ahead and write that out. This would be cups of flour. Let's figure out how much milk I should use. And I'm using the same kind of thought. Eggs over eggs could equal the amount of milk over the amount of milk. And I know when I use 5 eggs, how much milk would you expect to use is 2 cups of milk. But I've only got 3 eggs, so how much milk do you want to use? And what we'll remember is we'll cross multiply. 2 times 3, we got 6, is equal to 5m. Solving for m, we divide both sides by 5. And it looks like the amount of milk ought to be 6/5 of a cup. That would be really 1 1/5 cup. One more time as we start experimenting with proportions, let's figure out how much sugar would we need. I'm sticking with the limiting source, which is eggs. And 5 eggs is enough for 1.5 cups of sugar. 1.5 cups of sugar. But if I've only got 3 eggs, how many cups of sugar would you need? Let me make an S like that, standing for sugar. When I cross multiply, 3 times 1.5 is 4.5, is equal to 5 times S. Call that 5S. Divide both sides by 5, and the amount of sugar would be, in this ratio, 4.5 to 5, and I think we can simplify that. If I multiply, I just don't like the decimal 4.5. I'm going to multiply by 2 over 2, which is really the same as 1. So if I multiply this by 1, I won't change it, and that gives me 9 over 10. So I think I need 9/10 cups of sugar. So that's a little warm-up with some fractions, with some proportions. Let me just tell you some general thoughts. What is a ratio? I'm going to take a second and scribble this out. A ratio is a comparison of 2 numbers. Could be the comparison of the number of boys to the number of girls in a classroom. Could be how much milk do you drink in a day. It could be lots of things. Just comparing 2 numbers. And a proportion is when you have 2 ratios that are in fact equal. If I told you that 6 is to 9 as 10 is to 15, would that be, here's a ratio and here's a ratio, and I ask you, are those ratios equal? And you'd have to say, yes, they are. This is equal to 2/3, and that's also equal to 2/3. But something we should notice about this. To check this ratio, what I can really do is multiply the first one here times the 4th one there. 6 times 15 would give me 90 here. And the second one here times the 3rd one there, 9 times 10 is also 90. And since those cross products are equal, I know that this is a valid proportion. So I've started talking about those positions, first, second, third, and fourth positions. Let me take another look at that. In every proportion, we like to think there's first, second, third, and fourth positions. And in the first and fourth position, we have what are called the extremes. The extremes of a proportion fall in first and fourth position. And the means, and this is means like the term mean for average, the means fall in the second and third position. So here's what a proportion should really look like. And what we will need to remember forever is the product of the extremes is always equal to the product of the means. Always true for every proportion. And then, if we look at this page that you have, or that we need to be looking at, a first look at ratio and proportion, it has several proportions that we are to solve and find the value of x that makes the proportion true. I didn't think I could work it on that small page, but I think I can work it on this page. So I've written them here. And let's just burn through these and see how they go. The product of the extremes, if I were to multiply the first one here times that one, that would give me 40x plus 100 is equal to 42 times 10, which would be 420. Just want to solve this equation. Subtract 100 from both sides, and that would leave me with 40x is equal to 320. Divide both sides by 40. Here they drop off, and I'm just left with x. And I'm thinking, well, what about this? I can knock a 0 off of each one, and 32 divided by 4 would just be 8. So I'm thinking the value of x that makes this sentence true should be 8. Now let's check on that. 2 times 8 would be 16, plus 5 would be 21 over 10 is equal to 42 over 20. Yeah, that's a valid proportion. I can see if I doubled the 10, I would double the 21 to become a 42. So I know that this is a valid proportion. The cross products are equal also. 42 times 10 is equal to 21 times 20. Let's play again. This one has some bigger, uglier numbers, but I got a calculator. I think we can make that kind of clean up and not be so bad. I can do 4x times 112. That'd be 448x is equal to 56 times 24. And 56, oops, did I got that wrong? Just get that right. 56 times 24 gives me 1344. Yep, 1344. And I'll divide both sides by 448. And I'll find the value of x that makes this sentence true. I've got that 1344 on my calculator already. I'll just divide it by 448. Then it tells me the x is 3. Something you might have noticed from this proportion would have made it a little easier to work. You've been workable without a calculator. This fraction on the right-hand side is really equal to 1/2. So it would have been valid to change this to be 4x over 24 is equal to, and 56 over 112 is really a half. Now let's cross multiply and see what comes. The product of the extremes, 8x, is equal to the product of the means, 24. Divide both sides by 8, and I got x equal to 3 again. So I'm convinced that must be true. Let's play with this one. What would be the product of the means? Just reminding you that these are the means in the second and third position. 2 times 4x would be 8x minus 4. And the product of the extremes in first and fourth position would be 12x minus 24. Let's solve this. I got 8x on one side and 12x on the other. I'd subtract 8x from both sides. That would leave just negative 4 here. When I subtract 8x from both sides, I got 4x there, minus 24. I'm going to bring that negative 24 to the other side, and I get a positive 20. is equal to 4x. Divide both sides by 4, and I'm convinced that x is equal to 5. But I think I'd be clever to check everything I do, since I've been sick lately and I want to get this stuff right. If x is truly equal to 5, 3 times 5 is 15, minus 6 would be 9 over 2 is equal to, and x, let x be 5, 4 times 5 is 20, minus 2 would be 18 over 4. Oh yeah, that's a valid proportion, I can tell. When I double the 2 to become a 4, I double the 9 to become an 18, and these things are clearly equal. Here's a more interesting one. The product of the means, x plus 1, times x, is equal to the product of the extremes, 20 times 3, or 3 times 20. That'd just be 60. When I multiply here, I'll get x squared plus 1x. Oh wait, that was a 2x, wasn't it? So excuse me, let me make that be a 2x. So that would be 2x squared plus 2x, be careful there, is equal to 60. Because I'm solving a quadratic, I know I want to set it equal to 0. I'll bring everything to the left-hand side. 2x squared plus 2x minus 60 equals 0. I'm going to see if I can't factor it, but first thing I should think about is 2 is a common factor across here. So I'm going to pull that common 2 out, make it simpler to factor. 2 times x squared plus 1x minus 30 equals 0. And I will tell you that these are equivalent equations, and this will be easier to factor. We should keep the 2 just for good form, although it won't be a player, I understand. See about factoring this, and the factors of x squared would fall here and here, x and x, and now I need the factors of 30. It could be 10 and 3, could be 6 and 5, but I'm thinking that 6 and 5 is better because we have this middle term of 1. And 6 and 5 are different by 1. I know that this 6 times this 5 gives me a negative 30, so one of them must be negative, but the middle term is positive, so that makes me know that the larger product, the 6x, would be positive, and the 5x would be negative. And if we're to multiply those, let's go ahead and do that. I got x squared minus 5 plus 6 is plus 1x, last time's less than negative 30. Yeah, I've got it properly factored. And I know if the product of these three numbers is equal to 0, then one of them has to be 0. It's not going to be the 2, but it could be x plus 6 is equal to 0, or perhaps x minus 5 is equal to 0. And let's see what happens with those. X could either equal to negative 6, or perhaps x is equal to positive 5. I think we ought to check them both. Let's let x equal to negative 6. So this thing would have been 3 over, and negative 6 plus 1 would have been a negative 5, equals, and 2 times negative 6 would be negative 12 over 20. Number one, is that a valid proportion? Is it true that a positive is to a negative as a negative is to a positive? I said, yeah, that's valid. And 3 times 20 is equal to 60, and 5 times 12 is also equal to 60. A negative times a negative is a positive 60 there. So I say, yeah, that's a valid root. Let's check it with x equal to 5 as well. On this original proportion, 3 over 5 plus 1 would be 6. Right, that's a half, and it equals 2 times 5, there's 10 over 20. I can see that's a valid proportion. This is equal to 1/2, and that's equal to 1/2. So far so good. We're getting a couple things right. There are some operations on proportions that we'll be using in the next week or 3. I just wrote just a standard proportion. I think it's a valid one. And I'm going to use this series of operations on that proportion. And first we ought to agree, is this a valid proportion? You can cross multiply and see if those cross products are equal. But I can see that 9/27 is really 1/3, and 12 over 36 is also equal to 1/3. So that is a valid proportion. And first thing it asks me to do is switch the means. And what you want to remember is, in every proportion, there are these 4 positions. First position is an extreme, second position is a mean, third position is a mean, and the fourth position is an extreme. And if the guy says switch the means, then we got to switch the 12 and the 27, and the proportion would become 9 is to 12, as 27 is to 36. I ask you again, is that a valid proportion? And the cross products are the same as they were before, so it's got to be a valid proportion. And you might be looking at this and say, well, that's equal to 3/4. 9 over 12 is 3/4. And since 9 goes into both of those as well, 27 over 36 is also equal to 3/4. So yep, when I switch the means, it's a valid proportion. In this operation, I'm going to keep going back to the original proportion. And now I want to switch the extremes on the original proportion. And you're remembering the extremes are in first and fourth position. So if I were to switch those, it'd be 36 over 27 is equal to 12 over 9. I just switched the extremes, which is what I was told to do. And when I do that, is this a valid proportion? And I say, yeah, it is. If we did the cross products, it would be perfectly valid. Still, because I know that 9 times 36 is equal to 12 times 27. We saw that in the first case. Now, what about using addition? To do addition, you bring up the denominator and add it to the numerator. So let me write this out the first time, and the next time we'll do it a little more quickly. That'd be 36 plus 27 is to 27 as 12 plus 9 is to 9. Now let me just get this straight. 36 plus 27, I think that's 63. 63 is to 27 as, and 12 plus 9 is 21, as 21 is to 9. Is that a valid proportion, you might ask? I'm pretty sure it is, but I'm going to want to put a check on it real quick and see if we can agree. So let me just clear all the junk and just give a look at that and do 9 times 63. Hope I wrote that right. Yep, 9 times 63 giving us 567. And then the other cross products, that'd be 27 times 21. That might be hard to see, but 27 times 21 still gets me 567. So I'll say, yep, that's a valid proportion as well. We could use addition. You remember when you use addition, you bring up the denominator and add it to the numerator. What about subtraction then? Same idea. I'm going to go back to this original proportion and use what's called subtraction. I'll bring up the denominator and subtract it from the numerator on both sides. So this would become 9 over, and 9 minus 27 would be a negative 18 equals, and on the right hand side, 12 over, I want to bring up the denominator and subtract it from the numerator. Let's pause. Oops, I made a mistake right there. I can do that better. I want to bring up the denominator and subtract it from the numerator if I was using subtraction. And 9 minus 27 should have left me with a negative 18 over 27. Now let's do this right on the other side as well. I should bring up the denominator and subtract it from the numerator. 12 minus 36, that'd be a negative 24, is to 36. And you stare at this proportion and say, is that a valid proportion after you finally use subtraction correctly? And I think it is a valid proportion. This is equal to 2/3, a negative 2/3, because 9 goes into both of them. And this 12 goes into both of those. That would also be equal to negative 2/3. We could check the cross products, but I'm sure that they would be equal. And the last thing that we could do with a proportion is just to invert it. What does it mean to invert a proportion? That means to turn it upside down. So that'd be 27 is to negative 18 as 36 is to negative 24. Is that a valid proportion? And I'm sure that it is. So to practice those ideas, switching the extremes and using subtraction, inverting the proportion and using addition, I'm going to do those on this proportion that I just made up. I think it's a valid proportion, but we can check it and be sure it is. I'm going to clear all that stuff out and do what 12 times 28. And 12 times 28 gives me 336. I'll try 21 times 20. 12 times 28 and 21 times 20. Now that's 420, so that's not a valid proportion. Let me try that again. I got to write a proportion that is valid. And let me just think for a moment. If I divided that by 3 and then multiplied by 5, divide that by 3 and multiply by 5, oh, that'd be 35. Let's start with a different proportion, a valid one. 12 is to 21 as 20 is to 35. I got to start with a valid proportion if I want these other things to be valid. Now, I think that this is a valid proportion, but because I've made a couple of mistakes and want to get this right, I'm going to check on that. 12 times 35, that's 420. And what about 21 times 20? Yep, that's 420 also. So since the cross products are equal, I know that that's a valid proportion. And in this case, I want to do these operations successively, one after another. First, it has to be to switch the extremes. Hey, which ones are the extremes in this proportion? First and fourth position. And if I were to switch them, it'd become 35 over 21 equals, switching the extremes, so now I got a 12 down there, 20 over 12. I'm saying that's a valid proportion. And if I were to test it by looking at the cross products, I would have the same cross product, so I know it is truthful. This one has to be to use subtraction. I got that wrong last time, I'll get it right this time. I should bring the denominator up and subtract it from the numerator. 35 minus 21 would be 14 over 21 equals, and do the same thing on this side. 20 minus 12 just gives me 8 over 12. Hey, is that a valid proportion? I know that 8 times 21 is 168. What about 12 times 14? Yeah, that's still 168, so I'm happy with that. I say that's truthful. Then it asks me to invert the proportion. Now I'm going to invert the last proportion. I'm doing these successively. If I were to invert it, it'd become 21 over 14 equals 12 over 8. I know that that's also a valid proportion. I would have the same cross products as the last one does. What about if I used addition here? To use addition, you bring the denominator up and add it to the numerator, and 14 plus 21 would be 35 over 14. Let's do the same thing on the other side. Bring the denominator up and add it to the numerator. That's how we do addition. 12 plus 8 would be 20 over 8. Do we think that's a valid proportion? And if you reduce both these fractions, I think we'll agree that it is. 7 goes into both of those. That's the same as 5 over 2. 7 goes into 35 5 times, 7 goes into 14 twice. What about this fraction? Can it be reduced? Yeah, 4 goes into both of them. 4 goes into 25 times, and 4 goes into 8 2 times. Yep, this thing's absolutely valid. So back to this page. Let's check on this. If I were to switch the means, what would it become? The extreme would stay in that position. And this 15 is a 6 and a 15 are the means. I'd move them to these positions. And you might ask yourself, is that a valid proportion? And since both sides are equal to 1/3, I'd say yes, it is. Ask me to use addition here. To do that, why do you use addition? You bring up the denominator and add it to the numerator on both sides. So that'd be 5 plus 15 would be 20 over 15. And adding the denominator to the numerator here, we get 24 over 18. I'm thinking that's also a valid proportion. These are both equal to 3/4. Ask me to switch the extremes, and you got to remember that the first and fourth position are the extremes. I'll switch them, and it would become 18 over 15 is equal to 24 over 20. I just switched the extremes. And if I were to cross multiply and divide on that, I'm pretty sure we'd be happy and thinking it's truthful. 18 times 20 is 360, and 15 times 24 is also 360. Invert the proportion. Okay, so I'm going to go back to this proportion and invert it. When you invert it, you just turn it upside down. That becomes 15 over 18 equals 20 over 24. Yep, I've successfully just turned it upside down. I have inverted this proportion. Now it asks me to use subtraction. You want to be careful doing that. I should bring up the denominator, subtract it from the numerator. That will replace the numerator. So 15 minus 18 would be a negative 3 over the same denominator we had before. And on the right-hand side, bring up the denominator, subtract it from 20, we'll get a negative 4 over 24. And I say that's a valid proportion too. We ought to practice that in class and get more of those done. Let's look some more. If a teacher finds he can grade 6 quizzes in 15 minutes, how long would it take him to grade all 88 such quizzes? That's the kind of thing I got to figure out all the time. And let's see about this. There's lots of ways you could set it up. I'm thinking quizzes over quizzes equals time over time. But it is true that you could switch the means, and it would be quizzes is to time as quizzes is to time, and that would work just as well. But I'm going to keep it straight like this. I know I can do 6 quizzes in 15 minutes. So how much time would it take if I've got 88 quizzes to go? That's a pretty good place to use a calculator. I think I'll do just that. See if I can make it so you can see it. I'll just clear it up and see what I can do first. 88 times 15. 88 times 15, what do we get from that? Oh gosh, it's hard to see. That's 1320 is equal to 6 times t. I would divide both sides by 6. And how much time are we talking about there? I got 1320. I got to divide that by 6, is it? Yep. So it's 220 minutes. 220 minutes. Probably they say, hey, be back in 220 minutes. You say, oh, no, that's 3 hours and 40 minutes. I just had to figure how many 60s were in there. 3 times 60 is 180, so I had 40 minutes left over. So it took me 3 hours and 40 minutes to grade those quizzes, and that's really about right truthful. How many quizzes could he grade in 40 minutes? Well, I'm going to set up the same kind of thing. Quizzes is to quizzes as time is to time. And it goes back to, I can do 6 quizzes in 15 minutes. How many quizzes could you do in 40 minutes? Where should I put that 40? Yeah, these are minutes and minutes there, huh? So I should put the 40 right there. And I'll figure out how many quizzes there were here. 6 quizzes in 15 minutes. How many quizzes in 40 minutes? Let's cross multiply. 6 times 40 gives me 240 is equal to 15q. Divide both sides by 15. And the number of quizzes I can grade in 40 minutes would be whatever 240 divided by 15 is, and I'm thinking that's 16. I'll check on that with my calculator though. 240 divided by 15. Get that right. 240 divided by 15. That's 16. Yep, I can do 16 quizzes in that amount of time. Here's another look at ratio and proportion. A map scale reads that 4 centimeters is worth equal to 250 miles. The distance from Galveston to Mazatlan, Sinaloa on the west coast of Mexico is, I know it to be 1,050 miles. So what would that distance look like on the map? I'm going to go with centimeters on the map is to centimeters on the map as the true distance is to the true distance. That's just a little symbolic setup, so I know that 4 centimeters is the same as 250 miles. So how many centimeters would be on the map if I had to go 1,050 miles? So this is what we want to solve to get this thing figured out. And 4 times 1,050 would be 4,200 is equal to 250x. Well, that's a pretty good place to use a calculator, I guess, although if I did divide both sides by 250, maybe some things become apparent. I can knock a 0 off of each one. And how many times does 25 go into 420? I'm thinking 16 and 0.8, but I'll hit it with my calculator and guarantee that, see if I can't get that right. 420 divided by 25. Yep, I guess it's 16.8. 16.8 centimeters. would be the distance between the cities on the map. Here comes an interesting question that is different from what we've done so far. If 3 painters can paint a room in 5 hours, how long would it take a group of 8 painters to paint that same size room? And you might be thinking right away, painters over painters equals time over time. But truly, this is an inverse proportion. The more painters that come to work, the less time it would take to get the thing done. So, I'm thinking that we have something to be careful about here. This would really be set up with painters 1 over painters 2 equal to time 2 over time 1, because we have an inverse proportion. What makes it inverse? More painters, and it would take less time. If 3 painters can get that room done in 5 hours, oof, I've already made a mistake. In 5 hours, I've got to put the 5 down there. How long would it take 8 painters to get that room done? And I'm going to put a T up there for time. 3 painters takes 5 hours. How many would it take for 8 hours? For 8 painters. And 3 times 15, 3 times 5 gives us 15, is equal to 8T. Divide both sides by 8. The amount of time would be 15/8 of an hour. That'd be 1 7/8 hours. We can figure out how many minutes that are if we wanted to, but I'm going to stick with that. And what you want to remember is, if it's an inverse proportion, if more of one variable gives you less of the other, more painters uses less time, then you want to invert 1/2 of this proportion. I inverted the right-hand side. Here's a couple good questions more, and we're almost finished. Stick with me. If 6 times A is equal to 9 times B, what's the ratio of A over B? People get this wrong all day long. What you want to think is this A to B is really A over B, like that. And remember that A multiplies the number in this position, and B multiplies to the number in this position. A multiplies to the 6. So the 6 would show there, and B multiplies to the number in this position, and B multiplies to the 9, so it must be a 9. So the ratio A is to B is 9 is to 6. 9 to 6, just like that one. This is a really good question. We'll need to practice this one a little bit, I think. If 3P is equal to 7 times Q, and 2Q is equal to 5 times R, give us the ratio of P to R. This is a question that's not going to go away. At the end of this, we're going to figure out what's the ratio of P to R. That's really what this indicates right here. And what you want to be thinking, if we want to relate P and R, we're going to have to get rid of these Q's, aren't we? I like to call Q the middleman. I'm going to seek to eliminate the Q. I'm going to write this again. 3P equals 7Q, and 2Q is equal to 5R. And what I got to do is relate P and R. To do that, I'm going to ditch the Q. Watch this. I'll divide both sides by 7 here. And you would agree that those would cancel. And in this case, Q is equal to 3P over 7. Do the same thing on this side. Solve for Q. Divide this side by 2 and divide this side by 2. Here the 2's cancel. I'm just left with Q is equal to 5R over 2. And here we should be thinking, if Q is equal to this, 3P over 7, and Q is equal to that, 5R over 2, then these things must equal each other. Let me write that. 3P over 7 should be the same as 5R over 2. But this guy wants the ratio of P to R. Let's cross multiply. 3P times 2 would give me 6P. And 7 times 5R would give me 35R. So now, what's the ratio of P to R? Easy to make a mistake here. But P multiplies the number down there, and P multiplies to 6. So the number down there's got to be a 6. And R multiplies to the 35, and R multiplies to the number in that position, so the number in that position has got to be a 35. So I'd say the ratio of P to R is 35 to 6. Let's do another one of those. What if I told you that 6 pesos is equal to 20 yen, and that 15 yen is equal to $12? $12. What's the ratio of pesos to dollars? Now, I just made these things up, so it's not going to be truthful and valid, but we can check it through anyway. I want to relate P to D. I got to shake loose these Y's. After you've written these two equations, let's get rid of the Y's. The way I can do that is divide this side by 20 and that side by 20, but divide both sides of that equation by 20, and that would just leave me with Y is equal to 6P over 20. You'd be okay to call that 3P over 10, but I'm going to leave it like this for right now. Solve this for Y as well. Divide both sides by 15. And if I did that, Y there would be equal to 12D over 15. And if Y is equal to 6P over 20, and Y is equal to 12D over 15, since Y doesn't get to change, the yen doesn't change in the middle of this problem, then these things must be equal to each other. So I would say that 6P over 20 must be the same as 12D over 15. If I keep my act straight, I can figure out the ratio of P to D. Let's cross multiply. 6P times 15 would be 90P. And 20 times 12D would be 240D. P multiplies to the number in that position, and P multiplies to 90, so that number must be 90. D multiplies to the number in this position, and D multiplies to 240, so that number's got to be 240. So if somebody said, hey, what's the ratio of P to D? You could say 240 to 90, but it might be better to call it 24 to 9. But you could reduce that as well, huh? 3 goes into both of them, and that'd be the ratio of 8 to 3. Yeah. The peso to the dollar would be a ratio of 8 to 3. How about we do that one more time? And if you say, I already got it figured out, then that's great. Let's just say that 6x is equal to 9y, and 4y is equal to 8z. Hey, what's the ratio of x to z? With a little bit of practice, these things that seem complicated get kind of easy. Who's the middleman? Who do you want to get rid of here? We want to get rid of these y's, don't we? So we've got to solve these equations for y. How am I going to solve that guy for y? Is divide this side by 9 and divide that side by 9. Here the 9's cancel, and I think that y is equal to 6x over 9. Do the same thing here. I'm going to eliminate that y. Divide both sides by 4. Here the 4's canceled. I'm left with y is equal to 8z over 4. And if y is equal to this, and y is equal to that, yeah, I could reduce these fractions, but I don't care. I'm just going to work this through. If y is equal to these two things, then these two things must equal each other. So I'm convinced that 6x over 9 must equal to 8z over 4. Cross multiply, and we'll get the ratio of x to z here momentarily. 4 times 6x, 24x, is equal to 9 times 8z, that's 72z. So the ratio of x multiplies to the number down there, so x multiplies to the 24 down there. And z multiplies to the 72, so the 72 must show there. And I think I know what you're thinking. You're saying, well, x